614, how can I use variables to solve problems? Getting into some word problems here. Today you will learn to translate written information into algebraic symbols and then solve the equations that represent the written relationships. You will also explore a relationship involving distance, rate, and time. So a lot going on today. I gotta be honest, this is a pretty important lesson, so hopefully you guys are with it. Let statements or defining the variables, I think, is a big deal. I think if you can't do word problems, you really can't do math. I mean, you're never going to walk down the street and see this, but you might see a problem where you turn it into this and solve it. So, and then the distance equals rate times time problem is going to be something that comes up intermittently for a while. So all these things are things we need to definitely know how to do and be able to deal with. So we'll see how it goes. A zoo has two. So anyway, I'm sorry. So match each mathematical sentence on the left with its translation on the right. Make sure your team is in agreement with each answer before moving on. So a zoo has 2 fewer elephants than zebras, 5 times more monkeys than elephants, and the total number of elephants, monkeys, and zebras is 30. So let's see here. What if I said this is zebras? I have 2 fewer elephants than zebras. This would be the elephants. And I have 5 times more of the monkeys than elephants. So I think 1 and C probably go together. Zola earns $30 by working 2 hours and receiving a $12 bonus. So she earns $30 by working 2 hours and receiving a $12 bonus. So here's 2 hours. So and our $12 bonus. So I think A and 2 go together. 30 ounces of metal is created using zinc with silver. The number of ounces of silver needed is 12 times the number of ounces of zinc. So let's see here. 30 ounces of silver is the number of ounces of silver needed is 12 times the number of the ounces of zinc. Well, it looks like this one. I think 3 and D, right? So this would be the zinc and this would be the silver. And then Eddie earns $5 an hour. And he worked 2 hours longer than Zach, who earns $12 an hour. So here's Zach, here's Eddie. So we will say that 4 and B probably go together. So mathematical sentences like those in the left column of problem 631 are easier to understand when everyone knows what the variables represent. A statement that describes what a variable represents is called the let statement. For instance, let z equal whatever. I refer to as defining variables because that's what my teacher said to me. So, define your variables. Tell me what x means. Tell me what y means, etc. So, for example, for a mathematical sentence A above, which is matched with 2 translations, we could say z equals Zola's rate of pay in dollars per hour. Now that a let statement always indicates the units of measure. So write a let statement for B through D. So if I go to B, it looks like Eddie earns $5 per hour. He worked 2 hours longer than Zach, who earns $12 an hour. So it looks like Z is how many hours Zach worked, right? So let Z equal that. So I'll multiply how many hours he works by the $12 an hour. If I go to C, a zoo, I think this one the number of zebras, right? And then we subtract 2 from the number of zebras and we get elephants, and then we multiply the number of elephants by 5 and we get the monkeys. So I think Z was the number of zebras. And on this one, 30 ounces of metal is created by mixing zinc with silver. The number of ounces of silver needed is 12 times the number of ounces of zinc. So Z is how many ounces of zinc you need. You multiply that by 12 to get the ounces of silver. So that's what the Z's would equal in all of these equations. So one equation or two, and again, we maybe we didn't actually address this. We addressed something similar to it, but we'll see. Elsie took all her cans and bottles from her home into the recycling center. The number of cans was 1 more than 4 times the number of bottles. She earned 12 cents for each bottle and 10 cents for each can, and ended up earning $2.18 in all. How many cans and bottles did she recycle? So this is a great question to kind of talk about the way that I like to talk about word problems, but let's go through using one variable, and then we'll sort of chuck it, and then I'll go into how I'm going to ask you guys to solve word problems. So long story short, Elsie took all her cans and bottles. So Solomon wants to solve the problem by using just one variable, define a variable using the let statement, then write an equation that Solomon could use to solve the problem. So Elsie took all her cans and bottles from her home to the recycling center. The number of cans was one more than 4 times the number of bottles. So we'll say B equals bottles, a number of bottles specifically, right? And then what we can do is we can say that the number of cans is equal to one more than 4 times the number of bottles. So here we have B, here we're going to have 4B plus 1. I hope you guys are with me on that, because it says it's one more than 4 times the number of bottles, and we know that the number of bottles is called B, so I'll just multiply 4 times B and we'll get that. She earned 12 cents for each bottle, so we'll say it's 12 cents for each bottle, and she earned 10 cents. Oh, by the way, this should go down here. I'm solving the equation. And she earns 10 cents for each can, and the cans are known as 4B plus 1. And that's going to equal $2.18 in all. So we get 0.12B plus 0.40B plus 0.1 equals 218. We'll combine like terms and get 0.52B. At the same time, I'll subtract 0.1 and get 208. We'll divide by 0.52, and B is going to equal 4. So that means there's 4 bottles, which must mean that 4 times 4 is 16 plus 1. There's 17 cans. And again, we can check our answers. We know that a bottle is worth 12 cents, so that would be 48 cents. We know the can is worth 10 cents, that would be $1.70. And if we add that up, we get our 218. So this might seem real simple to do this in one variable, but we don't always explicitly get the relationship between these. In this case, we did, but we aren't always told how many more bottles there are than cans, or cans there are than bottles, or whatever. So the way we're going to do this now is the way I would probably tell you should solve your equations, and use 2 variables. So now you can see we use 1 variable, we only use B. But in this one, we're going to use 2 variables. I'm going to say, all right, we'll go over here. I'm going to say name B the number of bottles, and name C the number of cans. And again, I know that this might be a little bit trickier and you might not like this as much, but you're not always going to get that explicit relationship here. And when you don't, you're gonna wish you knew how to do with 2 variables. So I would say if you have 2 variables, you need 2 equations. 1 variable, we only needed 1 equation, right? So here's going to be our equations. First of all, I know that it's 12 cents for a bottle, and it's 10 cents for a can, and I know that I got $2.18. But I also have to have a second equation, and that second equation is going to be this one right here. That if I take the number of if I take, which one is more? The number of cans was 1 more. Okay, so if I take the number of bottles and multiply it by 4 and add 1 to it, I get the number of cans, right? Now I can use substitution. I can go over here and say, hey, look, this C equals 4B plus 1. So I'm going to go over here and I'm going to take the C out. So I'm going to use this original equation, 0.12B plus 0.12 or 0.10, and at C, I'm going to take it out and put it in parentheses, equals 4B plus 1, and that equals 218. And what I want you to notice is that these are the exact same now, right? Now, obviously, we did some extra work to get here. We were able to get here more quickly on the first one. Obviously, if I do the math, I'm going to get the same answer, 4 bottles and 17 cans. But I think you're best off is to read the question. And I know this sounds stupid, but literally read the question, because that's going to be what our variables are. How many cans and bottles did she recycle? I know how many bottles, how many cans. So that's what I'm going to define my variables at. Then I'm going to make my 2 equations. Then I'm going to combine my 2 equations, and then I'm going to solve my 2 equations. If you can do it in 1 variable with 1 equation, that's fine. But this is more flexible. This will work more often. All right. So let's go ahead and continue along. So I am in, I think 614B. It makes sense to me. All right, so after reading about earning money by recycling, Solomon and Marcus are excited to do some recycling themselves. Solomon has some electronics his parents said he could recycle. Marcus has permission to recycle some small household appliances. They looked online and discovered that the local recycling center offers 60 cents per pound for appliances and $1.50 per pound for electronics, but there's a $27 hazardous fee that has to be paid to recycle the electronics no matter how much you recycle. So write one equation that represents how much Solomon would earn by recycling electronics. Write another, the equation that represents how much you would earn from recycling appliances. How many pounds would they have to each recycle so they earn the same amount of money? So this is why I think that this is so important to read the question. And I know this sounds stupid. Read the question. Thanks, Olivera. That's super helpful. But in all sincerity, we're not asking about electronics and appliances. A lot of people would say, all right, well, how many pounds of electronics and how many pounds of appliances? But that's not what the question asks. The question doesn't say how many pounds of electronics and how many pounds of appliances. It says how many pounds would they have to recycle so that they had the same amount of money. So we could say X is the number of pounds recycled. It doesn't matter if it's an appliance or if it is an electronic. It's still a pound recycled. And Y is going to be the money earned. So again, I hope you get that subtlety, because it is very subtle, but it is very important. If you try and solve this problem as how many pounds of electronics and how many pounds of appliances, it's going to get tricky. But here we're told exactly what we're solving for. So now we can go back up and solve this. So Solomon has some electronics his parents said he could recycle. Marcus has permission to recycle some small household appliances. Again, so we've gone here, defined our variables. They looked online, discovered the recycling center offers 60 cents per pound of appliances and $1.50 per pound of electronics. But there is, okay, so I'm sorry. So I'm screwing this up myself. I apologize. So now we're going to come up with two equations. How much money is he going to get for his appliances? The money is going to equal 0.6 pounds, right? I'm going to take how many pounds he recycles and multiply it by 0.6. That's how much money he's going to get for appliances. So this is kind of the appliance equation. Now we're going to have an electronic equation. The electronic equation is his money is going to equal $1.50 per pound, but there's a $27 hazardous fee, so they're going to take $27 out of this. So if you were going to bring something that was like 5 pounds, you shouldn't, because you're just going to lose money, right? But now we have these two equations, and hey, look, this equals y and this equals y, so they must equal each other. I can solve the two together, and I will get negative 0.9x equals negative 27. I'll divide by negative 0.9. Obviously, a negative divided by negative is positive. A negative divided by negative is positive. I don't know what I just did there. 9 goes into 27 30 times, right? So x equals 30 pounds. And y is how much money. So if he recycles 30 pounds of appliances, he's going to get $18. Well, what should happen, if this goes well for me, is I should be able to plug 30 into this equation and get 18 as well. So think about it. 30 times 1.5, 30 times 1 is 30, half of 30 is 15, so that's 45, minus 27 is 18. So here's our solutions. 30 pounds will yield $18. It doesn't matter if they are appliances or if they're electronics. Either way, 30 pounds is $18. And again, I hope you see how important it was to read the question to figure out what it was asking to solve. Because if you went through and started solving this as electronics and appliances, I think you probably got in a lot of trouble on the equation. Probably, maybe not. All right, let's go ahead and keep going. So moving along, 6:35. Summertime camping. Morgan and her family are camping on their summer. Morgan decided to take a bike ride before it got too hot. She left camp and rode her bike at a speed of 16 miles per hour for 1.5 hours. How far did she bike? Morgan's dad, blah, blah, blah. Here's the bottom line. Distance equals rate times time. This is going to be one of the equations for these kinds of things. So we really need to make sure we're focusing on that and understanding how the mechanics of these equations work. A little bit different maybe than we're used to. So Morgan decided to take a bike ride before it got too hot. She left the campsite and rode her bike at a speed of 16 miles per hour. Well, that's your rate. She rode it for an hour and a half. Boy. My handwriting leaves something to be desired. What we don't have is the distance, but we can easily calculate the distance by multiplying, right? She must have 16 times 1.5 is 24. So she rode 24 miles. Now here, Morgan's dad went to get groceries at the campsite store and drove to the bottom of the mountain. He drove 20 miles per hour. So we know that his rate was 20, and he drove for 0.4 hours. Again, we don't know his distance, but if we multiply that, we will get that his distance equals 8 miles. 20 times 0.4 is 8. And finally, when Morgan's dad returned from the store, he went for a jog. He jogged for an hour and 15 minutes. Okay, so think about that. That's 1.25 hours. So we know that he went for his time is 1.25, right? At a pace of 4.5, so his rate was 4.8. And we need to know how far the distance was. Well, we can get that by multiplying 4.8 and 1.2. I think it's going to be 6 miles. But what we can do here is just quickly verify that 4.8 times 1.25 equals 6. Okay, now, here's the trick. I was under the impression that they were going to give us, we were going to solve for R or T. We haven't done that yet. So far we've only solved for D or for distance. So pretty simple so far. But we still see the mechanics of how that works. So it says each of the parts of problem 635 involve 3 units of measure. You were given 2 and then calculated the third. What 3 units of measure were common? Distance, rate, and time. Write a single equation. How about distance equals rate times time? All right, so let's go ahead and answer question C. Taylor, Morgan's older sister, will be driving from her house to the campsite tomorrow. She averages 65 miles per hour, so that's going to be her rate. It's 195 miles, so that's her distance. So the question is, what's the time? Well, we can divide by 65, and we can see that 3 hours equals the time. So finally we get one where we're not solving for distance. On this one we solve for time. While camping with her family, Morgan took her puppy to the river. The river has a current of 27 feet per minute. Okay, this one's a little bit kind of funky, but that's fine. So while camping, if you imagine the river's going one way, the puppy's going the other. They're working against each other. I don't think science is really involved here, but the idea would be that if the puppy went 44 one direction and the current went 27 the other way, that the net would be 17, right? So for 8 minutes. So the rate here, we want to know how far did this thing go when it was going 17 feet per minute for 8 minutes. And it would have gone 80 plus 56, 126 meters. So again, while camping with her family, Morgan took her puppy to the river. The river has a current of 27 feet per minute. The puppy paddled upstream, so it was like 44 minus 27 was the rate, and it did it for 8 minutes. So we solved this equation. to get this. I think it's 126. Maybe my math is wrong. It says review your work from Part D. If you did not include units, put units on each of the numbers in the variables in the relationship using dimensional analysis. Verify the distance, rate, and time. Okay, so what they're saying is that we need to go here. I really don't want to. But distance is equal to 17 feet per minute for 8 minutes, right? So the minutes cancel out and what's left is feet. Although I wrote meters. There we go. So I guess dimensional analysis is a good idea to get the correct units, but you can see the minutes cancel and what's left is feet. All right, at that, I think I need to pull up the last one and finish this section off. So I think it's for this one right here. So we've done that. So now we're on to 637. Taylor and Morgan would like to spend some time on the river while camping with their family. Taylor wants to rent a 2-person kayak. There's a $5 setup fee for kayak rentals, and then kayaks are rented for $8 an hour. Morgan notices a sign below and says, look, a canoe is actually cheaper if we rent one for a long enough period of time. Write 2 equations to model this situation. Use the equations to determine the number of hours it takes for the canoe rentals and the kayak rentals to cost the same amount of money. Again, reading the question, we're talking about hours and money. We're not talking about canoes and kayaks. Of course, canoes and kayaks are going to be important. We're going to have an equation for each, but we're going to say X is the number of hours rented and Y is the money spent. And I hope you see the difference between that and saying like C is canoes and K is kayaks. That's not how it works. Read the question and figure out what you're solving for. Define your variables that way, and it should make it easier to write the equations. So now we know that Taylor wants to rent a 2-person kayak. So we can have a kayak equation and we can have a canoe equation. The kayak equation is a $5 setup fee and then the rent for $8 an hour. So the money spent is $8 per hour plus a $5 fee. That's how much kayaks cost. Canoes have the money cost $6 an hour and there's a $9 setup fee, right? So we have these 2 equations. So we know that they both equal Y, so they must both equal each other. I'll solve this equation. We're going to get 2x equals 4, so x equals 2 hours. And then now, when I plug 2 in, here I get $21. And I'm just going to confirm when I plug in here, I better get 21 as well, and I do. So that's going to be our solution. Again, read the question to define your variables or write your let statements. I think that makes these a lot easier to have it. I really want you to get into.